Hello and welcome to Science with Mrs. B, NTI edition. Thank you for joining me today for NTI day number 1. We're actually beginning a new unit in science. We're going to start talking about physics, which is basically the study of forces in motion. So over the next couple of weeks, I will be doing my physics unit here on Google Classroom and on YouTube. So we talked about how all this is going to happen before we left school. And so thank you for joining me. Don't forget that if you need anything from me, you can contact me through email, cell phone, or you can call the school's number. Also on Google Classroom, you can private message me. So let's go ahead and get started today. So our unit, like I said, is physics. Today we're going to focus on how do we describe motion. What are the ways that we can talk about how things move? Because in order to really talk about forces in motion, we have to have some vocabulary that we discuss. So let's just go ahead and start with an example. Okay, let's say this is you, and you see a friend. So you can describe where you are standing in that room in a few different ways. One of the ways that you could describe where you're standing is based on how far you are standing from your friend. Okay? And so you could measure that. Also, let's say you're talking about where you live. Okay? And maybe you're talking about where your school is. So if you were going to tell somebody where your school is located, you're going to have to use something else in your description. You're going to have to use a reference point. So you might even choose to use your house as a reference point. A reference point is a place that we choose to describe the position of something else. So if I were to talk about how far away the school is from my house, I might choose to say, oh, the school is a mile away from my house. It isn't. That would be nice. But the position of the school I have described using a reference point. Okay? So remember in my example with you and your friend, you were describing where you were in the room with your friend as your reference point. Okay? So in this case, you might be 10 inches away from your friend, or your school might be 1 mile away from your house. But every time we talk about motion or where something is, we use a reference point. There aren't any rules for what you can use as a reference point. You might say, I'm standing 10 inches away from my friend, or I'm 16 feet away from the door, or my friend lives 15 miles away from me. It doesn't matter. All of those statements had a reference point. So I want you to take a moment. And the good thing about using YouTube to teach is you actually get to do this at your own pace. So don't forget the power of pause. If at any time you want to pause this video and take some notes, write things down, think about it, walk away, go to the restroom, you can pause me this time. You don't have to raise your hand and say, may I go to the restroom? You can pause, but actually I'm going to ask you to pause right now because I want you to pause and think. What are 2 ways you could describe your position right now? So I'm going to give you a minute. Go ahead, hit pause. And once you've thought about it, hit unpause and we'll talk about it. So I'm assuming that you paused. At least I did. So the way I would describe my motion right now, or my position, sorry, not motion, my position right now, is I'm saying that I'm sitting in a chair that is approximately 8 feet away from my television. Okay, so that's how I would describe my position. That description uses my television as the reference point. Or I might even say I'm sitting about 15 feet from the door, or 1 foot from my dog. So those are all using reference points. So let's talk about this a little bit more. Let's talk about how we might use this in real life. So I'm going to use Disney World as my example. So this is a map of the Magic Kingdom, which is closed right now, by the way. So we'll visit Disney World in our minds today. And again, if you've been in my class, you know how I feel about Disney. So here's a map of Disney World, and you can see all the different lands in the Magic Kingdom here. You got Frontierland, Adventureland, Tomorrowland, all of that. and I'm going to show you with my mouse right there is Cinderella's castle. And so this is just giving us a real life example of how we might use reference points. So I actually did a little research and found a website that tells you the actual distances to and from different places in the Magic Kingdom. Let's say that you were going to visit somewhere like that, and you wanted to know how long it took you to get to Cinderella's castle. So in this little picture, it shows us that from the entrance to the park down here to Cinderella's castle, it's about 358 meters or 1,176 feet. So in this case, the reference point to Cinderella's castle is the entrance. Here's another one. Cinderella's Castle to Space Mountain, one of my favorite rides ever, is gonna be about 1,091 feet or 332 meters. So again, now instead of the entrance being our reference point to Cinderella's castle, we have a ride, Space Mountain. That's our reference point. And if you've ever been at a place like this, any large place, whether it's Disney World or another park, Kings Island, or even if you're meeting your friends downtown, you're going to use a reference point to talk about where your position is, okay? And so in this case, we've got, we can compare where Cinderella's castle is to Space Mountain. This is interesting. This talked about the two furthest points at Magic Kingdom, and this is just a little tidbit. I never realized this, so if you were there, the two farthest places away that you would have to walk would be Splash Mountain to Fantasyland train station. So the two farthest places away. So the reference point for Splash Mountain is the train station and vice versa. So anytime we're talking about positions, we always have to have a reference point. And this is one of those things in science that's kind of common sense. Once you start thinking about it, anytime we discuss a position, we have to use a reference point, okay? So now that we understand reference points and how we describe position, let's talk about another way that we can describe position. We can describe position as being positive or negative. And anytime in science or math that we talk about something positive, we use a plus sign to show that. And in negative, we use a minus sign, to show that. So in physics, one thing as you progress farther in your study of physics past 7th grade, when you take science in 7th and 8th grade, and 9th grade all the way up through high school, one big thing is you have to really pay attention to the directions, positive or negative. So what do I mean by that? You actually give certain directions a positive or negative, and this actually is not that difficult to think about. So in this little picture I have here, some of the ways we might describe motion or position as positive is if something's going forward, it's positive. Up is positive. Right, positive. East is positive, and north is positive. And then the opposites would be negative. So backward would be negative, down would be negative, left, west, and south would all be negative. And this just helps us give a plus minus. Now, just as a real life application here, this is how they use GPS coordinates. A lot of times it's in positives and negatives when they do all of that. And by the way, a little math connection here. We have plotted points on the coordinate plane, our x's and y's, okay? And remember, if we go up on the coordinate plane or to the right, those coordinates will be positive. If we go left or down, they will be negative. So this isn't something that is new. You've seen this before. And this is why the coordinate plane and things like that matter, because when we start talking about physics, we talk about our motion as positive or negative. And over here on the left, I even have a little graphic that shows a little basket with balloons and weights. If that basket were to travel up, okay, it's in the positive direction. Down would be in the negative direction. So here's another way to look at that same idea. So let's say that we are talking about a city, and you're going to go some different places, okay? We've got a library, a bus stop, and a museum. To the right is east. To the left, obviously it's not shown, but that would be west. And each of these little marks are 20 meters in this model away from each other. So let's say that you wanted to go from the museum to the bus stop. So the way we would describe that position would be that the bus stop is 80 meters west of the museum. Now, how did we get that? Each of these little marks is 20 meters, so 2, 4, 6, 80 meters west of that museum. Now, again, reference point. If our bus stop is the reference point, okay, then we could also say the bus stop is 40 meters east of the library, okay? So you can have multiple places, multiple reference points to help you describe motion. And even more important, when we say the bus stop is 80 meters west, we're talking about the negative direction. When we say the bus stop is 40 meters east of the library, we're talking about the positive direction. So here's the big idea that we're making our way to and understanding all of these things. Motion is just the process of changing position. So we said physics is a study of forces and motion. We're going to talk about motion first. And all motion is the process of changing your position, going from one place to another. So let's go back to that idea of you and your friend. We said that if you're describing where you're standing in a room, you might say, I'm standing so far away from this friend, okay? So let's say that you are beside your friend and you are 6 inches apart, okay? So you're 6 inches apart, and let's say you walk a little farther away from each other to where now you are 6 feet apart. So we have changed our position. Motion has happened, okay? So let's actually add a little bit of math to this. Don't be scared, okay? Math helps us understand science way better, and especially with physics. So we're 6 feet apart, all right? And let's kind of see how far we've moved, because we said we started out being 6 inches apart. Now we're 6 feet apart. Let's do a little conversion. So 1 foot equals 12 inches. That means that 6 feet would give us 72 inches, okay? And we started out 6 inches apart, remember that? So 72 inches minus 6 would be 66 inches. So when we moved away from each other, we moved a distance of 66 inches. Now, distance is just the path that you follow, the amount of inches, centimeters, miles, kilometers, meters, whatever you're using, that you have moved, that you have changed your position. That's what a distance is. So our distance now is 66 inches apart, okay? Now here's a new word, displacement. Displacement is how far you are from where you began, okay? So how far you are from where you started. Now we started being 6 inches apart in our little picture, okay? And our distance was 66 inches apart. We moved that far apart. And our displacement is also 66 inches. We moved 66 inches from where we started. Now, let's pretend that we moved 66 inches apart and then we stood back together. We decided to talk again. What happens then? I'm going to let you pause one more time to think about that, because this is something that you might have to take a few minutes and digest. So I want you to think about what happens to your distance if you have moved far apart and then moved back together, but what also happened to your displacement in that situation. And you can go back in the video and look and think about that, but I'm going to encourage you to pause for about a minute and think about that. Okay, hopefully you unpaused, hopefully you followed my directions and you paused and thought about that. So what is happening if these two people moved far apart from each other? They started out as 6 inches apart, they moved farther away to 6 feet apart, and then they moved back together. What would happen? Well, our distance, okay, we moved 66 inches apart, and then we had to go back 66 inches to go back together where we initially started. So that means that our distance was 132 inches. We have moved a distance altogether of 132 inches in that little situation. Or if we wanted to convert it, that would be 11 feet. And the way that you would do that is take 132 inches divided by 12, because there are 12 inches in a foot, and that gives us 11 feet. So throughout that scenario, standing together, moving apart, moving back together, we moved 11 feet. What about our displacement? Now remember, displacement is different from distance, because displacement is the difference in where you started and where you ended up. Well, in this case, we came right back to where we started. So we were 66 inches apart. We moved 66 inches back together. Now remember how we used positive and negatives in describing motion? Okay, so we moved 66 inches apart. Okay, that would be negative. And then we went 66 inches back together. That would be positive. So 66 minus 66 would give us 0, which is 0 displacement. There was no displacement at all. Now we moved a distance of 11 feet, but in that we began right where we started. So what this means is that your distance is how far you go within a certain situation, okay? And your displacement is how far away you ended up from where you started. So you can go very slowly and have a large displacement, okay? Or you can stay right where you started and have a large distance. So these are ways that we have to think about speaking about physics. So just to recap our little video today we talked about reference points and how those help us explain where something is in the big world around us, and how anytime we talk about the location of something, we do it in reference to something else. I'm sitting on the couch. I'm standing in my schoolroom. All those are examples of reference points. We talked about position, okay? A position is where you are in relation to a reference point. We talked about positive and negative direction. Positive being things like up and to the right or forward, and negative being to the left or backward or down. We also talked about motion being a change in your position. And finally, we talked about how distance and displacement were different. You can go a long distance with 0 displacement. And that's my favorite example of that. So, just a reminder, these are all the things that we've talked about today. I'm going to post another video later this week. This video, as well as the assigned readings on Google Classroom, are going to help you do the assignments that I have posted on Google Classroom. So do not forget to go to Google Classroom right now and do those assignments. If you need me, you can email me, text me, message me on Google Classroom, whatever. I am here for you. But don't forget to actually do these assignments and turn them in. And by the way, you can watch this YouTube video as many times as you need and pause it wherever you need to. That's why I posted it. So just another little reminder. Make sure that you are constantly washing your hands, make sure you're not touching your face, and that you're staying safe and doing all your work. I miss you all terribly, but I'm happy to be able to post some videos for you, and I hope to hear from you all soon. Have a wonderful day.